Hello and welcome back to Let's Code Physics. We are in our final video of the rope simulator series. This is the end of my spring semester. I've got some new things starting up over the summer. So now seems like a pretty good time to call season 2 to a close, go on a brief hiatus. Couple of announcements before we get to our last rope simulator video. One is that my brother Kyle and I have decided to start a new podcast. We just recorded the first episode 2 days ago, so it should be going up soon, probably around the same time that this video goes up. You can look for that on YouTube as the Square Root of Nerd channel, or you can find it on Twitter at Square Root Nerd. We talk about video games, scientific discoveries, our own personal productivity and entertainment habits and things like that. And it's a lot of fun. We had a really good time making the first episode. We're really happy with it, and we think that our viewers will enjoy it. Another big announcement is that I'm going to be at the American Association of Physics Teachers summer meeting in Sacramento, California this July. I will be speaking about Let's Code Physics in one of the first sessions on the morning of Monday, July 18th. That's session AC. I'm going to have some giveaways available for everybody there, and I'll also have a big announcement about one of the next major projects coming to this channel. So if you come to the AAPT meeting, you can be one of the first people to hear about the big announcement. So we've been playing around with this rope simulator. We've managed to get it to where we can click on the rope to cut it, and the goal is to get the green ball into the basket here. I last time added this wind effect where we can add in this horizontal wind component to help push the candy along toward the basket. And that's been really fun. That's been neat to work with. What I'd like to add in next is not just a horizontal wind velocity, but also a vertical wind velocity, so that way you could potentially move the candy in any direction that you need to. The animation is running a bit slower than it was last time. I think my computer updated something somewhere and now it's hogging some memory. I'm not sure. I'm going to take a look at that off camera after I finish today, so that hopefully by the time season 3 rolls around, things will be running back up to speed again. So let's do this. Let's see. So I want to set it up to where the wind has a vertical velocity and a horizontal velocity. And I think the way I'm going to, one of the first things I'm going to do is I'm going to set up a horizontal slider for the horizontal velocity and a vertical slider for the vertical velocity. So one of the first things we should do is look for the slider again, this wind slider. And let's change that to wind slider X. So let's change everywhere we have wind slider to be wind slider X. Cool. If event.pick equals wind slider X, then you do these things. Wind slider X. Cool. And then we'll basically copy that and do the same thing for the Y. So if object equals wind slider X, adjust the wind velocity X component. The idea would be that the player could then adjust both components, and that way they could, kind of fine tune where the ball moves. So let's see. Let's actually do this because I already have all this set up to be in the Y direction. Then let's set this up down here. We can just copy and paste, and then do the same thing with the wind slider in the Y, which I haven't made yet, but I will. Adjust wind velocity Y component, and then we'll change this thing's Y, change this thing's Y, dy, VW max, nice. Let's see here, and let's make this one now. No, that's fine. Yeah, we can have the VW max be the maximum for both the X and the Y. That's fine. We'll go with Y. Wind arrow.x equals vel1. Actually, that's great because then the wind arrow can point in any direction. That'll be great. Object.position. Actually, let's have So this was one thing that I ran into when I was testing this, is you can keep dragging the thing, the arrow won't move, then you drag that down and the arrow starts to decrease. So we're actually going to take this part where we move the object and we're going to move that under here. So if it's greater than VW max, I don't want it to do that, so else we're going to put that part in here. So it's only going to move the the slider if it hasn't exceeded the maximum. Cool. If absolute value of vel_wind is greater than yeah, that's fine. It's the absolute value, so it'll work going up or down. Cool. So now I need to do the same thing here for the x component. So let's have this thing be going in the x direction. New position x, velocity x, dx. Cool. If absolute value of that is equal to that, okay, again, we're going to move this piece up just like we did before. We're going to make that an elif. Elif, how do you pronounce that? Let me know in the comments. Object position.x gets added to it dx. There you go. fdeg_pig_j. I am trying to embrace the plus equals symbol. vel_wind.x. Okay, cool. Awesome. So that should set that up for both the x and the y. Let's keep looking for wind slider. Okay. Now I need to update this to be wind slider x and wind slider y. Let's see here. Let's actually put that in here as well. Wind slider x, wind slider y. Oh, and I need to do the same thing with wind slider y here, because I needed to actually drag the wind slider. Fit.pick equals wind slider. I just make this one now y, make this one now y. Rock and roll. Let's see here. I need wind slider y. All right, let's look for wind slider again. Okay, we've taken care of that part. Let's look down here for wind slider. Okay, cool. Okay, cool. So this is now going to function well as wind slider y because it's already set up in the y direction. So no sense in changing it if it already works. And then this part's going to be wind slider x. And all I should have to do, should be dangerous when physicists say that, is just swap all of the x and y items. So I swap the x and the y. And then for position, I think I ought to be able to just swap those. If it turns out bad, I can always change it. That's why I love programming much more than experimenting, because you do an experiment wrong, you might have wasted a sample. If you do a computer code wrong, well, then you just restart it, you know. I know you waste computer time, it can be expensive, etc. Okay, cool. Do I need to fix wind slider anywhere else? Doesn't look like it. And the force code for the drag should already be, for the damping force, should already be set up, because it's just vel list of in minus vel wind, and that vel wind is already set up to update all the vector components appropriately, right? Let's see, vel wind. Let's see, because we're updating vel_wind.x, we're updating vel_wind.y. Cool, so that should be enough. I know it's scary whenever I start a sentence with that should, because you get things like an invalid syntax. Where did I go wrong? Elif. Oh, whoops, I actually need, that needs to be an else, not an elif. Doesn't matter how you pronounce it, Brian. That shouldn't have been an elif to begin with. Well, there's an elif down there. Let me know how you pronounce it. I'm curious. Elif, elif. If you defined a variable called ant, can you have elif ant? Good night, everybody. All right, so let's see here. Okay, cool. So this thing needs to have a little bit more room to move. So I need to change the scale by which this thing moves. And then I adjust this. Oh, that's so cool. Look at that. I'm changing the wind vector. All right, so let's see what happens. Maybe I can decrease the dt, or increase the dt a little bit to make this thing run a little bit faster. Oh, cool. You see it's being pushed in this direction. It's got a little bit different trajectory to it than before. Let's do this. Let's increase the time step. Let's maybe increase it by a factor of 5. And then I need to, let's see here, for these wind sliders. Wind sliders, it sounds like a really healthy tiny burger, wind slider. Let's see, for the wind slider, I need to change the velwind.x equals velwind. Let's change this 10, because those things can move by a whole lot more, I think, to give us better control. Let's change that. There we go. Whoa! Oops. Problem. That was a major problem. Don't do that, Brian. Oh gosh, what did I do there? Okay, so velwind.x, velwind.x, dx equals new position. That was strange. Oh, you know what? That might have been the time step. Yeah, that was the time step. Oops. Okay, so I need to put the time step back, apparently. All right, fine. Go away. There you go. All right, let's try that again. Put everything back to the way it was. I don't know what I did. All right, dt's back to where it was. 10 times dx. Those are back to the way they were, F5. Okay. Okay, no multiplication error there. Let's actually see what happens if we put this thing the wrong way. Here we go. Let's see. Can I get into the basket by wind power alone? Oh, doesn't look like it. Doesn't look like it. Oh, it's falling down. Oops. Come on, just a little bit more. Okay. So let's maybe increase the VW max as well. Okay, so let's try changing these down to 5. This is just to give me a little bit better control over the slider. Okay, yes, I have a little bit better control there. Okay, let's drop the 5 and let's change those 5s into 1s. And actually, let's call something wind fac for wind factor. Wind factor. Go ahead and spell it out. Sorry, I know I say this a few times. I was raised on Fortran, where you can't name things, or at least you shouldn't name things longer than I think it's like 6 characters. So I have a hard time breaking that mold. Let's go with a 1.0 for wind factor. Maybe it's 6, maybe it's 8. I don't know. All I know is I hear my advisor's voice in the back of my head. That's too many letters. Let's see. Okay, yeah, that allows me a lot better control. Cool. And let's actually increase the VW max. Okay, where is it defined though? All right, search up. There we go. Okay, let's increase this to maybe a 3.0. Let's maybe double that. Because what I'd like to be able to do is, at least in this game, get the candy into the box by sheer wind power alone. Oh, that is a larger wind vector right there. Probably gonna need to change the scaling on that. Because ideally what you can get is you can get the drag force to be greater than the weight of the ball, and so then you can have it push the ball effectively, move the ball upwards. All right, let's maybe get it accelerating to the right a little bit too. And it's falling in, it's falling in, it's falling in. I think we're gonna make it. I think we're gonna make it. We did it. We got the ball in by wind power alone. Actually, it occurs to me I could do a little bit of physics. I could do a little bit of calculation here to get that maximum correct. Let's do a little bit of math here. Because that is going to depend on the game, but also I should be able to figure out an ideal value just based on the winds. Let me open up a whiteboard here. We'll do a little bit of math together. Any day now. There we go. Okay, so let's think about it this way. So if I want the damping force to be canceling out the weight, right? The damping force is this damping coefficient times V, gonna equal the ball's mass times whatever my G value is. Okay, yeah, so my V, let's call this one the maximum. So my maximum needs to be at least mg over b, right? So let's maybe make that, like a 1.5 times that. Cool. Let's make it like 1.5's mg over b. Awesome. Okay. So VW max, let's make that one 1.5 times, what's the mass? Where do I save the mass of the candy? Candy. Where'd you go? Highlight. There you are. In candy. In candy. In candy. Oh, I'm searching up. Excuse me. Let me search down instead. All right. Search down. In candy. Okay, fine. Candy's in the basket. Did I not give the candy a different mass? I don't think I ever did. Well then, mass. Oh, I gave them all the same mass. I never gave the candy. I never gave the candy a different mass. That would explain why it just floats so easily. Okay, let's actually, Okay, let's actually change that a little bit now. Let's see, let's change mass to an array. Let's see here, where do I start all of my arrays? Just to make it a little more mass list gonna equal 0, list of elements of atom/candy masses. Okay, so where do I get into all of the list stuff? Okay, cool. So here's where I get into a lot of the lists. So what we're gonna do here is we're gonna say mass list dot append mass, and then do the same thing here because that mass is gonna be the mass of the elements. Mass list dot append mass. And then let's make the candy, here I can do the same thing, mass list of n minus 1, because here I'm adjusting the atoms previously, so I can adjust the mass previously. Let's make it 10 times the mass. All right, where else do I have mass? Okay, so we're going to make this mass of n, because I'm inside an n loop there. Okay, that's awesome. Mass of n, awesome. Okay, let's give that a try. Oh shoot, I never actually finished this part. Okay, let's change. Actually, yeah, let's go ahead and finish this one out. So this is going to be 1.5 times the mass. So let's make this. Okay, let's make candy mass going to equal 10 times mass, just so that way I can. This is so that I can reference it later and only have to change it once if I need to. So let's go down here. So instead now of having this be 10 times mass, we'll just change it to candy mass. Okay. VW max is what I'm looking for next. Okay. 1.5 times the candy mass times, what did I call that? Grav, I think we called it. Yeah, grav divide by the damping coefficient B. Yep. Okay, cool. Let's see what happens there. No syntax errors. Okay. But there is a problem with, oh, excuse me, mass list of n. Pardon me. Okay, there we go. 5. Okay, cool. So now this thing should behave a little bit differently. And let's, whoa, that is, okay. I need to change the scale. I forgot to check what that number actually was. Let's change the scaling for that axis. Oh, that should be wind arrow axis equals vel wind divided by our times, let's call it wind arrow factor. Global wind arrow and global wind arrow factor. We'll make that something small like 0.1. Where does wind arrow occur? Because that arrow is, it's supposed to be there to help you get a visualization, and instead it's being obnoxious. Factor, wind arrow, okay, wind arrow factor 0. Let's go with 0.05 even. Okay. Once again, okay, let's go up here. Okay, cool, and that's the maximum. Okay, so now it's designed so that the wind force is greater than the weight, so it is able to push the ball up. Now let's get a mighty wind blowing the thing downward. Oh, that's cool. That's cool, cool. Okay, let me change one other thing. Because, see, part of the problem is these things are experiencing the same damping force, the part of the rope and the part of the candy. The candy should be experiencing a greater damping force than the rope. So to make this a little more realistic, I need to do one more thing, and that's turn the damping coefficient into a list. So let's call it B list. To blist, to be stressed. Double hashtag list of damping coefficients. Let's look for, I have to go down, now wherever I update the mass list, I have to do the same thing here, or the same thing with this. So let's go with list.append of B. I need to do the same thing, don't I? I need to have a B. So let's make that one super smaller. There really shouldn't be that much damping force on the rope itself. Most of the damping force should go to the candy. Candy damping coefficient. Oh, that should be something other than B, shouldn't it? B candy. There we go. All right, B list.append B down here. B list of n-1. Oh, I have an inconsistent naming convention. Candy B instead of B candy. It'll drive me nuts later when I come back to this. Candy B. Pardon the rattling. An animal has decided to play with a fridge magnet on the dining table. Oops, excuse me. Candy B. Candy B. And then down here I need to do the same thing. blist.append of B. Okay, now let's look for damp. B of N. There we go. Damp. All right. Save. Let's try that one. I did the same thing. You would think over the course of 10 minutes I would learn to not make the same mistake, but no. Okay, cool. All right, so now this should be... I just changed that. Did I not just change that? Oh, right. Sorry, I'm dividing by too big of a number now. So let's go with candy B. I'm dividing by too small of a number. There we go. Forgot to fix that part. Okay. Okay, cool. I think I'll also eventually move this arrow off to the side or something so it's not interfering visually with the candy animation, with the candimation, if I may. Okay, cool. So we've got it enough to make this thing float upward. So if you like, this is an alternative to the bubble in Cut the Rope. The bubble was a clever idea and it solves the problem of what happens if the candy falls below where it needs to go, but I just find that bubble so irritating. I'm sorry if that, offends anybody or bursts their bubble. All right, so what I would need to do here would be to see if I could get this thing to fall a little bit. So I need to decrease. I've got it with a pretty decent horizontal velocity. Oh, might need a little bit more vertical velocity. So this is kind of cool because you're not really controlling its velocity. You're controlling the velocity of the wind that impacts the force on the candy. Right, so it's not like you're controlling it directly. There's a delay there, which is kind of cool. So I think there's some neat physics to learn there. Oh, no, too much in the vertical, Brian. Too much in the vertical. All right. Well, I'm gonna keep playing around with this, see if I can get it to go in. I think this is a pretty neat take on cut the rope. Oh, now it should. Now let's see if it bounces all right off the top of the basket. Okay, so now I need it to go back. So anyway, this has been a pretty neat take on on the general idea of cut the rope. I kind of like having the wind controls a little bit more than the blowers. There's a little bit more physics behind it, but I hope this gives you an idea of some of the fun stuff that goes on in some of your favorite computer games that involve ropes, that involve wind forces, that involve all this stuff. This has been a fun project to undertake. I'll probably bring it back out and dust it off to try some more things with it. But thank you so much for watching. This has been a really fun series, and I will see you next time. Bye-bye.